All right, question number 13. Something from kinetic theory of gas. Volume this much, 25 liters of cylinder is there with 1 mole, and oxygen gas, diatomic, room temperature has been given. The molecular diameter and the root mean square speed has been given as 0.3 nanometer and 200 meter per second. So that's the RMS speed. We need to calculate the average collision rate. So the collision frequency, that means 1 upon the relaxation time. Okay, so the required parameter which has been there, that is quite obviously equal to VRMS divided by the mean free path. And what is the expression of the mean free path? Well, that is 1 by root 2, you remember, right? So that comes out to be 1 upon root 2, and small n is the number of molecules per unit volume into pi r square. So that is the given thing. Say root 2 n pi r square, where small n is the number of molecules per unit volume. Now let's try to see. VRMS is given. Now if I want to calculate number of molecules per unit volume, I need to be very particular. This is not number of mole, but yes, number of molecule per unit volume you can calculate, because 1 mole, so therefore the Avogadro's number would be the number of molecule. The volume has been given, the radius is also given. So you put all these things and you calculate, the answer would come very close to this. So the collision frequency is in the order of 10 raised to the power 10. That was question number 13. Now let's move to question number 14. Nucleus, more precisely modern physics, nucleus and radioactivity. Now you could see that this is already the third question from modern physics. While I said modern physics, I've also included the semiconductor one. So that area, specifically the modern physics, is quite a fertile one. So this is the piece of advice that I would like to give to my viewers who fall into the future aspirant category, that modern physics, by the time it comes, it's a point which saves you, because questions are straightforward and lots of questions fall from this segment. Okay, so here's the radioactive one. Two radioactive materials A and B having decay constants 10 lambda and lambda respectively, if initially they have the same number of nuclei. All right, the initial number of nuclei are same. We need to calculate the ratio of number of nuclei of A to that of B will be 1 by E after a time. Though the initial number of nuclei is same, with time the number of nuclei would be different. Reason being straightforward, the decay constant of the material is different. So we need to see 1 by E. So that's the ratio of number of nuclei. For the first one is n naught e raised to the power minus of 10 lambda t divided by n naught e raised to the power minus of lambda times t. So that's all. And you know, solving, you could easily get t equals to 1 upon 9 lambda. That's another, again, a very straightforward one. Fine, let's move to the 15th one. Well, with the 15th question, we reach the halfway mark. So that gives a bit sigh of relief. And electrostatic, more precisely capacitor, a bit of modification, but yes, again, a straightforward. But I have seen that candidates, when they see the graph, initially, just by seeing the graph, they start coming in the back foot, but it should not be. In fact, as you start approaching step by step, you would see the solution is kind of quite easy. Now it says figure shows Q versus voltage, okay, Q versus V for series and parallel. So one is series, other is parallel. That's what we need to see. That means there are two capacitors and this is Q versus V graph. Out of A and B, one is in series, other is in parallel. And to identify that, it's not a difficulty because the slope of the graph is the net capacitance with the expression Q equals to CV. The slope in graph number A is higher as compared to slope in B, therefore A should represent the parallel and B should represent the series, okay? And here it comes, Q equals to CV, so C is the slope, and here that would be the net C. Now the first case, you could see that the slope is 500 by 10, which is 50. I would prefer to keep the unit in microcoulomb and V in volt itself, because that would give me capacitance in microfarad, and that is matching with the given option. So 500 by 10, which is 50, and that will be equals to C1 plus C2, okay? And eventually, the second one of B, you could see, is, 80, 10. So the slope here would be 8, and 8 is C1, C2 divided by C1 plus C2. There you go. We got two equations, two unknown. You just make a small amount of calculation. You would get C1 and C2 as 40 microfarad and 10 microfarad respectively. So option number 1 is the correct for question number 15. There you go. The halfway mark has been crossed. Now let's go to the 16th question.